Hi, boys and girls. This is lesson 3.8, part 2. We're still going to be working with ordered pairs. The last time I left it up here on the screen on the last video, we talked about the 4 different quadrants. So we had 1, 2, 3, and 4 going in clockwise form. So that's not the gist of what I'm going to talk about in this particular video today. Today it's about a reflection. This is something else that you have to know. So when you have a reflection, you can look at a coordinate plane. It completely, the x-axis and the y-axis literally cut everything in half. So when we have something has line of symmetry, the line that divides the figure into the line of symmetry is the one, I'm sorry, let me rephrase this for you, that divides something completely totally in half like this. So like the y line right here divides the coordinate plane exactly in half vertically. And the x-axis right here divides it exactly in half going horizontally. Now the two sides have to be a mirror image of each other, like looking at yourself in a mirror. That's what symmetry is. It has to be exactly the same on both sides. So the other thing that you have to be able to do here is you have to be able to tell if 2 points are a reflection on a coordinate plane. So, for instance, let me go ahead and switch here. All right, so let's take a look at this coordinate right here, the negative 1, 3, and the negative 1 and negative 3. If you look at these two particular coordinates, now we're going to look at a line of symmetry across the x-axis is what we're going to be looking for. So when I look at these two coordinates, you can just look at it and see that it's 1, 2, 3, to the line of the x-axis, and it's 1, 2, 3 places up, and it's exactly mirroring each one another. So these two are mirrored across the x-axis. Okay, so it's across the x-axis. You understand? Because literally, if I take and fold this like a sandwich on the x-axis, those 2 points would touch one another. So I want to make sure that you understand that. Now, there is another way that you can do this by looking at the coordinates themselves. So let me erase this real quick. I'm going to write down those coordinates. So we have a negative 1 and a 3, and we have a negative 1 and a negative 3. Okay? Oops. Sorry about that. It's my computer. A negative 1 and a negative 3. Now, I want you to notice that one of these coordinates is the same. Do you notice that this one right here is a negative 1 and this is a negative 1? Okay, when the coordinate is the same, this is the x-axis. Since it's the x-axis, this is the one that I'm reflecting across. Okay, so this is the one that, sorry about that, this is in the way. I'm reflecting across, it's right here. Okay, so if the coordinate is the same, that is the one that you are reflecting across. Does this make sense? Okay, so if I had, oopsies, my bad. I remember to change my pen. All right, so now if I wanted to, let's say, I want to reflect across the other coordinate here. We've got a 2 and a 4. And across here, I have a negative 2 and I have a 4. Okay? Which coordinate is the same? Is it the x or is it the y? All right. The one that's the same is the y coordinate. So I'm reflecting across the y axis. Okay? So this is my reflection. That word reflection. All right, boys and girls, this is a little bit harder and a little bit harder to do, but you can do it literally by looking at your picture, as we did with the first one here, and you can see that the same point is is across from one another across the x-axis, or you could do it with the coordinates themselves. In this case, the 4 is the same, therefore we are reflecting across the y-axis for those 2 points, the one that is right here and the one that is right here. All right, boys and girls, thanks for joining me. Happy math.